Yeah, so today I'll be talking about GitOps, which basically, before I jump in, let me just talk a little bit about myself. So I'm principal consultant at Lab3, and I have more than 15 years of working in cloud and networking. I create content, create videos on YouTube and blog posts, and these are the social media where you can find me. So yeah, so like the first thing is that like what is the big idea really? So what is GitOps? We heard today from Luke, who talked to us about platform engineering, and which is another way of doing deploying or provisioning your infrastructure. But again, GitOps is not here to replace DevOps. It sounds that every now and then someone else is trying to reinvent DevOps, but GitOps here is a bit different. So the question here is that what really is GitOps? Is it a tool? Is it a framework? Is it a methodology? And of course, the answer is all. So GitOps is that like as is like officially defined by the CNCF, by Open GitOps Group. GitOps is a modern way for deploying cloud native applications. Basically, GitOps makes your Git repository the single source of truth. You would have your configuration declared in for your Kubernetes cluster, your deployment manifest, your service manifest, your Helm chart, all all stored in Git and versioned and controlled by Git. And of course, your manifest is defined in a declarative language. What a declarative basically means is that you just tell Kubernetes what the environment should look like. You don't tell it exactly how to do that. That is for Kubernetes to figure out. And again, GitOps is about automating the deployment. So what that means is that, which we'll see in a minute, again, instead of you having to actually write your own, you write your script and your configuration as code, you put it in a pipeline, and then you push, and then that deploys to your environment. Git actually changes that. So I have seen a lot of documentation that says that defines GitOps as deployment by pull request, as opposed by pushing the code into your cluster. And finally, what GitOps is that it's a continuous reconciliation. And reconciliation words sound like a bit abstract. What it means basically is you have an agent that is continuously looking at your Git repository, checking and syncing that is the desired state, whatever you told your Kubernetes to provision for you, is it actually matching your current state? And that is called a reconciliation. If it finds that it drifts, it would sync it to what it sees in Git. So GitOps is based on, or built on 4 key principles. This is a standard that was built by the community and standardized by the CNCF and the Open GitOps org. If your Git setup does not actually follow this, you can't call it GitOps. It needs to be, again, declarative. For example, in this case, you would tell it, run 3 replicas of my application. And replica is just basically the number of pods that contains your application, how many pods run in your cluster to represent your application. It also needs to be versioned and immutable. So versioned, of course, is if you store it in Git, any changes to it and you commit it, that is going to be versioned. But immutable means once you push your configuration to your system, you're not allowed to go and change it manually. You have to create a new version of your configuration and push the new one. That is what it means to be immutable. Finally, also, it needs to be pulled automatically. Again, unlike the CI/CD pipeline, where you put your manifest and script files in your pipeline, and then push it to your cluster. This is actually the other way around, where if you commit your configuration to your Git repository, the agent would detect that, hey, something is actually changed, and it goes and pulls those changes and apply it to your cluster. And again, finally, it is continuously reconciled. Now, if you read through a lot of documentation from GitOps, you'll find a lot of mention of something called the GitOps loop, or like the continuous reconciliation. So what does that mean? So the GitOps loop is basically, you could define it in 3 words: declare, detect, and correct. You declare your desired state in Git. If your GitOps agent, your Autopilot, detects that there is a drift, and the drift, what does constitute as a drift? Say, for example, that you defined in your Git repository, you said that I want you to have 1, 2, or 3 replicas of my application. And someone came in manually because of some load, and your application is not holding the demand, so decided to increase the number of replicas to say 5. That is a drift because someone changed the system manually outside of GitOps. So the system would, after an interval, you actually configure, it would go and check the Git repo and say, like, hey, the Git repo is telling me that I should actually have 3 replicas, but my Kubernetes cluster is telling me that we have 5. So what it does, actually, it will delete 2 of your replicas. So that is a drift, or a correct. And also, for example, say that someone made a mistake. So like someone is pushing a code and they do not realize they're not actually pushing to the right Kubernetes cluster, and then all of a sudden their configuration has actually deleted a namespace, like a complete environment. That is not a problem for GitOps, because what happens is that, again, after that interval, that could be, like, by default, it could be 1 minute, it could be 1 hour, depending on how aggressive you want your GitOps to check the Git repo. So I would go and I was like, hey, this thing, if it's like a production and if we set it to 1 minute, and 1 minute is going to check and say, like, hey, this actually is not right. In the Git repository, it tells me that we have a namespace for our store, like online store. So like it's a authentication, or like the basket, cart, whatever it is, and it does not see that in your cluster. What it does, it will provision again. So that those are considered like a drift that will correct a drift from a problem. But also, which we'll see again in a second, there is another way when it actually, in a good way, it would detect a drift. I'll talk to that in a second later. Yeah. So, like, finally, where does that leave us? Does that mean that that GitOps should replace the CI/CD pipeline? That GitOps should that CI/CD pipeline is bad and GitOps is good? No, not really, because both CI/CD pipeline and the GitOps work together. So nothing's stopping you from using the CI/CD pipeline like normal. So like you would write your own code, you push your code to a Git repository that will trigger a CI build. Your container is stored in a container registry. That should not stop you from using the CI/CD pipeline, because you have a lot of testing, a lot of measures that you would have within the CI/CD pipeline. We need to continue that. But what we need to stop is that you taking the whole deployment all the way to the cluster. Instead, what needs to happen is that when you push a new code, the GitOps agent will need to detect, like, hey, something changed. There's a new version of our application. It will pull it and actually deploy it. So that means that you could have both of them working together. And then the other thing is that the benefit of actually having GitOps is that GitOps is continuously checking your system. So, for example, in a CI/CD pipeline, what happens is that you run your pipeline, it works, and then that's it. It does not continuously check, like, hey, did actually the state change from what I applied? You can't do that. By design, is the CI/CD pipeline is called ephemeral, which basically means it runs once, it applies whatever you ask it to apply, and then it stops. The GitOps on the other side, it keeps on checking your environment. And of course, finally, the other security aspect here is that when you want to push from your CI/CD pipeline to your cluster, you need to give your cluster access to the your CI/CD pipeline access to the cluster, and that is like a security risk because your CI/CD pipeline could be compromised. The GitOps agent on the other side is actually a service, a controller that is sitting within your own environment, within your own Kubernetes cluster, and it is going and checking a Git repo to say like, hey, is the status changed? If not, it will do nothing. But if it found that it changed, it would apply it. No need to give an external system access to your cluster. Right. So now what does life with GitOps looks like in a development workflow? So in here, normally a developer would just like write the code, push it to a Git repo, that triggers a build for a container, and then that container is stored in a container registry. Next step in the pipeline would be to run kubectl command to actually deploy this new container image that you have built for your environment. The difference here with GitOps, and this is where I said like both GitOps and CI/CD pipeline could actually work together, is that once the work, you would stop the work of the CI/CD pipeline before it hits the deployment. And what happens is you have your Kubernetes manifest, your Helm chart, all stored in a Git repository. When you create a new container, that comes with a new tag, and that is reflected in your configuration in your Helm chart to say like, hey, actually deploy this new container image. When GitOps in the GitOps agent, whether that be Flux or Argo CD, those are the two most common and popular GitOps agent. They're both CNCF projects. When the Flux CD or Flux, as they call it, and Argo CD detects there's a new image, that's when say like, hey, this is also considered a drift. That is a good drift. What I mean by that, because it's something new, you want it to actually apply, and that's why the project Argo CD called them Argo CD. CD is for continuous deployment. So that is basically in their name, and Flux is also doing the same. So they give a whole new name to the actual deployment. So that in this way, like you push your code and immediately get deployed. If your environment is drifting from, or like there is a change, or that's update, or it's a mistake, it would reconcile it, and your cluster is automatically updated. So yeah, long story short, that's the whole idea of GitOps. That's the power of GitOps. The idea here is that you would use the Git as the single source of truth. Whatever, like your Git repository basically becomes your documentation. You're 100% sure if like the GitOps agent is doing, like if there's like no problems, the GitOps agent is like reflecting whatever you have in your Git repository, that you don't need to second guess and say like, hey, is actually what I have here is reflective of the cluster. You're no longer afraid to push new code because you could just compare it with what you have in your Git repo. You don't have to go and check the cluster and make sure like, hey, maybe someone did a change because of an incident or like an increase in load. If I go and make changes, I'm not aware of their changes, I'm going to overwrite it and cause a problem. Git would fix that problem because all those changes is actually in Git. All right, so now maybe demo guys be with us. Let me see, how can I present my screen? Share screen, and then all right, hopefully this is going to work. And is it working, or am I sharing the wrong screen here? Wait a second. Let me stop sharing. Sorry, guys. I need to move the StreamYard to another window and share again. A window. And yeah. Yeah, are you guys able to see my screen? All good? All right. Hopefully. Yeah, so what I did here is that I have created a public repository on my on my GitHub account. You could find it here. So basically, that GitHub repo contains all the discussions that I was talking about here. It contains all the guidance, and it is still work in progress. I have created. I'm modeling it over days. So day one, where I just talk literally about all the things that I've talked about here in much more detail, right? And day two is our demo. So what I'll start with here is that I'll start with a local demo, which should make our life easier. And later I'll connect our Azure Kubernetes cluster. So I'll go quickly through the setup. So basically, for us, for our demo, we need to have Docker installed, like Docker, either Docker desktop or like the Docker engine. We need to have kind, which basically lets you run a Kubernetes cluster locally on your machine within a Docker container. We need to have kubectl, which is a CLI command to help you interact with the Kubernetes API, and of course Git version, because that will help us push code. If you later on, we'll go and read through the GitHub repo. You could fork this repo so that you could interact with it using your own repo. So it's a public repository, and you don't need any credentials to work with it once you fork it. And the first thing here is that we'll create a Kubernetes cluster for us to work with. I'm going to copy the commands from here, so to make it easy for us to work with, and you don't have to see me typing. I'm aware that we only have less than 10 minutes. So basically what I'm doing here is I'm creating a Kubernetes cluster, and then later on I'm going to step-by-step connect it to install Flux into it, and then connect Flux to my GitHub repo. And then after that, Flux will start to deploy the applications that our application that we have defined. So right now it says our cluster is working. So kubectl, we need to see. As you see here, so we have created a single node. In this case, this node is called the GitOps loop, and you might notice that it's only the control plane. Normally in Kubernetes, you would have a control plane node and a worker, but because it's a simple setup, we don't need a worker node. We'll just settle with one node. The next step here is that we'll just explore our manifest file. So the manifest file, you will find it in here in the examples and in the cluster. So in the examples, I created a folder for day two. In here, you'll find the deployment YAML. You'll find the namespace YAML and the services, which are all our configuration, what you normally would commit to your Git repo and you would use to build your own environment. And if we go back to the article, so in here, what we're doing is that if I go through it quickly, as I said, the folders are created in a way to mimic a real environment. So the local means it's a local environment. This could be in a real environment in dev or staging. And the apps is hello. In our case, it's just a hello app. It's basically we're going to run an Nginx container. So that container is really just plain text. It's just going to say almost like your application is working. Then here we are defining a deployment file. And deployment file is just like a way for us to tell Kubernetes, hey, I want you to create my application with this configuration, create one instance of this application, give it a label of hello, and use this container, right? So that's basically it. That's what it's saying. It says like, hey, the container is going to be accessible on port 80. Again, for the service, this is the service again. The service is a way for us to talk to our application, because if you want to talk to the application, you would need an IP, but because the pods in Kubernetes are ephemeral, so they could spin up and down, and they change IP a lot. So what we do is I use a name for it, and that will give us a name for our service. And with that, let's jump into installing Flux. So what I actually missed to talk about here is what is Flux. Let me see if I could find it in here quickly. Yeah, so Flux is our CNCF tool. Basically, it contains it will come with a set of controllers or custom resources within Kubernetes. One of them is called the Git repository, and one is the customization. So the Git repository is basically talking to the source, like where is your code is sitting. So it's in a Git, it's in a storage account. And the customization controller is the one who is actually applying. So you have two resources. One who say like, okay, I will keep an eye on this Git repo. I'll keep on caching and copying the details of this repo into the cluster. And the customization is the one who is going to actually apply it. So yeah, again, quickly with the time, we've already got Flux, the Flux CLI installed. These are all the commands that will help you to install Flux. So before we start, we need to make sure that we are in the right Kubernetes cluster setting. So yeah, that tells us like, hey, you are on the current GitOps loop. Let's quickly.
Ahmed,
yeah.
Thanks. If you're in the console, can you bring it up and show it so we can see what you're doing?
Oh, sorry.
No, that's all right.
sharing the window. I don't know. It's not sharing the. I thought it's sharing the. Sorry. Let me stop sharing. I thought it's sharing the whole window or entire screen. All right. Unfortunately, it can only share. All right, let me see. I have to spin. All right, let me see if I. Are you guys able to see my screen?
Yes, we can see both the console and the.
Yeah, unfortunately, I literally have to spin myself because the camera's on the other side. Right. Yeah, so sorry guys. Yeah, this is what I was doing. So basically we would create cluster, that will create the cluster, and then we'll double check all the nodes here are correct. So it says you have the GitOps loop demo, and before we apply or install Flux, really, we need to double check that we are on the right cluster. And a simple command is just like that. You just say Flux install. And with that, what happens is that the Flux CLI will pick your Kubernetes cluster, and it goes through and install all the details that it needs. And basically, it says hey, your the biggest controllers that we'll talk about is the customized, the one we are interested about. The source is the one who checks the source, and of course, Helm will check the Helm repository here, and the notification is just a way to. All right. Yeah, as a way to send notification to say Slack or whatever, right? So what happened here is that after we install the Flux, I'll skip the verifications. What we need to do is to basically tell Flux where is our Git repo. So if we copy this command here and paste it, of course I need to change it here because I put it as your username, because when you fork your repository, it will show your username. So I'll change it to the name of my repository. This is basically now telling Flux hey, this is your repo. You go to the branch main, and in every 30 seconds, check if there is any change in this repository, right? And then after that, the customization. In here, what we're doing is that we're telling it, you know that Git repository that we called it GitOps log demo. That's the one you need to check. Go exactly into this folder, the example day 2 cluster, so on, and then every 1 minute apply. If you find something removed from that repo, like if I delete a replica or whatever, go ahead and prune it. So those two are now done. So what happened now is that basically I'm giving control for my cluster to Flux. So moving forward, Flux is going to actually control the my Kubernetes cluster. So if we say, let me know what Flux get me the customization, it says like, hey, I'm in control of your hello application. And the most important thing here is to say ready is true. So and also if we want to see like what type of services or application it provision for us, and it just like that, it says like, hey, I have provisioned a service for you, and then this is the actual IP. So sorry. Yeah, so like long story short, we have not used any kubectl command. I have not told it to go, hey, and apply this YAML on manifest files. I just said Flux install, and I told it Flux, this is the repository, this is the folders that I want you to check. And the one last trick I want to see here, if we have some time, is that we could actually cause a problem to our cluster right away. So what we do is that, you remember we said like create one replica for our application. I'm going to make a manual change here and drift my cluster intentionally. I'm going to say like, hey, scale the replica to 0. So I say like, hey, yeah, it's scaled. So that is a drift for us. Hopefully I'll catch it quickly before I change. Yeah. So as you see here, it says like your deployment is now, you have 0 and all of, yeah. And immediately it's like, hey, that's not right. In your Git repo, you said the replica is 1, and it figured out that this is a drift and went ahead and corrected it. And yeah, you could even go as far as deleting the whole namespace of your application, and it would go back and recreate it for you. Let's see if that works, and hopefully we'll catch it in the action. Yeah, so like basically all these commands and everything that I'm doing here is in this Git repository. Yeah, so what this command is actually going to do now is going to say like, hey, let's watch what all the events that will come from the hello application. And in a minute, the Flux repository is like going to say like, hey, this whole namespace is actually not available. That's not right. In the actual Git repo, you have you told me that there is a namespace called hello. I think it will take a minute. Oh yeah, there you go. And it says like, hey, I'm scaling the replica set, scaling successful, scheduling, pulled the image, created it, and started. So yeah, just like that, like it will come back from an error. And for the sake of technical accuracy, this is the actual set of commands that will help us. I was like intending to work on it for the Azure Kubernetes Service. So like this is an AKS cluster that I have created. I will connect it to my shell command, and then I'll check everything here. It would like if I run these commands and install Flux, I would basically go ahead to my AKS cluster in here. This one, as you see here, as of now there are no namespaces beside the default one. Yeah, should I go and work on this one, or do you want me to stop here?
We're actually past time.
Yeah, let's stop it.
Is there any final comments you would like to make before we wrap up?
Yeah, this repo is going to be, like, I'm going to work on it even more. I'm going to include examples about Argo CD. I'm going to include even more advanced examples. So if you like to follow or like start that repo, I will be adding more content to it. And yeah, you might have a question like normally a lot of people when they think about Argo CD and Flux is that why two, or like which one to use. If you are like Flux is like really lightweight, and Flux is really much easier because there's an extension for AKS to actually install it. You don't need to do a lot of the scaffolding. Now there's a new, like I think it's in preview, there's a new Argo CD extension for AKS. And of course, Argo CD comes with a user interface, which is much easier to actually work with. But again, it's preference. Both are powerful. Both has their own use cases. And yeah, back to you, Shemaine.
Thank you so much, Ahmed, for the overview and the live walkthrough. I'm sure it was very helpful for everyone who's watching. We're just going to wrap up now, so please stay online, and we will do our final commentary on the Auckland Global Bootcamp. Thanks, everyone.